going to learn about limits and continuity. What should come into your mind when you hear the word limits and continuity? From the word itself, you can actually differentiate to say they are talking about the end of something. For example, we have been given this question, which is saying the limit as x approaches 2 of this function, which is x over 2. There are two methods in which we can work out this one, but in this case we start with the first one, where we get a number that is closer to actually 2. In this case, when we get a 2.1, when we replace where is x with a 2.1, we find that we are having a 4.1. When we get a number that is again more closer to 2, we find that we'll get actually a 4.01. So this should actually tell us that as we are approaching x to 2 in this function, we are getting closer and closer to 4. So the limit as x approaches 2 of this function is actually 4. But there is also an easy way of doing things where we'll get this same function. We fact out this thing where we are having x minus 2 over x minus, so this thing will cancel each other, so we will have a x plus 2. So as we approach x plus 2, here we have a 2 plus 2, which is actually 4, like it gave us in the previous question. So we also have another question, that is x squared plus 2x minus 4 as x approaches 5. So when we see that when we replace directly here, we'll find that we are getting a 31. So as x approaches this, we are getting a 31. The reason in the first place that why we didn't, it should give us a defined number. For example, if it gives you 0 over 0, it means it's undefined. You need to factor out. So in this case, it's just given us a direct number. It's actually defined. So we also have x cubic over 27. This, yeah. So as x approaches 3. So in this case, when we get it, we'll have a 0 over, when we replace direct, we're having a 0 over 0, which is actually undefined. So we need to factor out the top part. How do we factorize this one, the top part? Save this. We have the formula. You should save this formula. Factorizing this top part, we have this b over a squared plus a b plus b squared, where actually a represents x and b represents 3. So in this case, we have 3 to the power 3, which is actually 27. So b actually here represents 3. This is how you go about factorizing the top part. You should master this formula, it should be in your heart. So when we save this, don't trouble. When we replace where there is a, we replace with x, we find that we are having x, and where there is b, we find that we are having 3, close brackets. Where there is x, where there is a again, we replace with x squared. Where there is a, we replace with x. Where there is b, we replace with actually 3, and plus b again, which is actually 3. So when we approach mind you, here we have an x over 3. So we have factorized the top part. This will cancel each other. We only remain with this part here. And when you place a 3 in where there is x and where there is b, we replace a 3 here. We replace a 3 like we did on this side here. We are finding that we are having a 27. So the limit of that function is actually 27. So we also have certain cases where we have x over this 1 over x minus 3. We have this. They tell us to find the limit of x as the limit of the function as x approaches 3. So we notice that on top we have fractions. The first thing that we should do is actually multiply the lowest common denominator of the fraction, which is 3x, also multiply down here by 3x. So find that you have on top here, when we multiply here, we have 3 minus x over 3x minus x minus 3. So we find to say this is what we have. The down part, let us not do or temper with anything. So this thing here will just be one and the same when you factor out the negative here. We factor out a negative, we find that we are having an x here minus 3, just one and the same. So we observe that the top part and the bottom part, they look similar, so they cancel each other. So down here we find that we are remaining with 1 over 3x. So now it is possible for us to approach x to 3. So we have 1 over negative 9 as our limit in this case. So don't forget, we started by multiplying the lowest common denominator of the numerator on both sides. So we came up with this. So after coming up with this, we noticed we wanted to make the denominator this and the numerator this to be similar. That's why we factored out a -1 here. So after factoring out a -1, we remained with this. Now it became similar and it cancelled each other. We remained with a -1 over 3x, and that's now it was suitable for us to actually replace where there is x, we replace with 3 to get a 1 over -9. So we have also another case where we have a square root of 3 of x over x minus 9 as x approaches 9. So notice something, when we just replace directly, we find that we are getting a 0 over 0, which is not the case that we want, which means it's undefined. But how do we deal with this problem? How do we deal with it? So the first thing that you should know is notice something here. You have a square root minus 3. So the first thing that you should do is actually multiply actually by the conjugate, which is actually a plus 3 over x plus 3. So when we multiply this with the top part, save this, don't jump. When we multiply this with this and this with this, find that we are getting x plus 3 minus 3x minus 3. So we'll get the down part, we won't temper with it, but we multiply it, but we won't temper with it. So when we find that this one and this one will go, will remain with an x minus 9 over x minus 9 with the denominator plus 3. So notice something, this one will be similar, you cancel each other, will remain with the top with 1 over the x plus 3. So right now it is possible for us to approach x to 9. As x approaches 9, so it won't give us a 0. We'll have this, which is when we replace with 9, we'll have this, which will actually equal to 1 over 6. So the limit of that function that we are given, hope you did not rub it as well, is actually 1 over 6. So that's the basic knowledge that you should understand about limits. Don't forget to subscribe to the channel and join the WhatsApp group for more updates. The limits. What should we know when it comes to infinity limits? First of all, I will show you some theorems that you should master in as much as infinity limits are concerned. The first theorem that you should master is, you should know that limit f x equals limit 1 over x as x approaches infinity. So what should you know when it comes to this is that when we get 1 over infinity, it simply means it will equal to 0. But how is it equal to 0? In this case, when you start getting a number, let's say you get 100, then again you come and get 1,000 or a million or a trillion, you see or notice a pattern to say this function will be approaching 0. So as x approaches infinity in this function, you will see it is equal to 0. So these are the basic things that you should master in as much as infinite limits are concerned. So we have an example, which is the limit of 5 plus 1 over x. Now as x approaches infinity, what should come into your mind first? You have to analyze the question that you have been given. In this case, we have been given this question. So what should come into your mind? Should come into your mind is that you replace where there is x with infinity, and you will notice to say this function here, it will equal to 0. So you find that 5 plus 0, and in the end you will find to say you have 5. So in this case, as x approaches infinity in that function, you are getting a 5. Let me also show you another example where you have been given the limit x squared as x approaches negative infinity. What should come into your mind first? You have to break this down, you will notice to say this is just the same as here, when it's just the same as times. Even here it's times with multiplication. You notice to say as we approach this function to negative infinity, we're just getting a 0. So we'll find that x, the pi of 3, the squared, we multiply it by 0, another 0 multiplied by 0, you're getting a 0. So the limit as x approaches negative infinity in this function is equal to 0. So these are the basic things that you should master as much as limits of infinity are concerned. So we'll also look at limits at infinity of rational functions. For example, you have been given 5x squared plus 8x minus 3 over 3x2 plus 2 as x approaches infinity. So what should come into your mind first? First and foremost, we learned to say you should deal with you multiply this, you get rid of the highest power. In this case, what we can do is 1 multiply all this by, you multiply it by this. So once we multiply everything inside by 1 over x squared, we'll get rid of the highest power. What will remain with is limit 5 plus 8 over x minus 3 x squared over 3 plus 2 over x squared. So in this case, we will find that when we approach x to infinity, you will find that here we have 0 and here we have 0, as well as here 0. So we have 5 plus 0 plus 0 over 3 plus 0, which is equal to 5 over 3. So our limit is 5 over 3. These are things that you should master in as much as limits of infinity are concerned. So we are also going to look at trigonometric functions and their limits. So before we go any further, I would like to introduce these two theorems, where we have the limit of sine x over x is equal to 1, and the limit of 1 minus cos x over x is equal to 0. So these are the basics that you should master. You should know them by heart. Even when you are sleeping, you should be able to remember when someone wakes you up. So dive into the examples. Don't cancel this. Dive into the examples where you have been asked to find the limit of tan x over x. when x approaches 0. So we find that when we depress directly, we are getting this, which is not what we are looking for. So we are approaching it to 0. What's the first thing that you should do? We know that tan is equal to sine x over cos x, and we have an x here. So one thing should actually trigger us into our minds. The first thing that should trigger us into our minds is when we do the algebra and everything here, we are getting, don't trap this, we are getting a limit of sine x over x multiplied by 1 over cos. Here we have a multiplication. So this should actually communicate something to us. So we learned to say when we approach x equal to 0 of this, we are getting a 1. So, and when we approach this 0 here, it is actually, because 0 it's actually 1, and 1 over 1 is actually 1. So we find that the limit of this is equal to 1. So these are the things that you should know. Actually, they are very, very important. So we have been given this example, which is cos squared x minus a over sine squared x minus 1. In this case, we are approaching it, x is approaching pi over 2. So when we approach x equals to pi over 2, so the first thing that you should notice is identity in this identity. We actually know to say it can equal to negative cos x squared. When we go back to the identities, we find that it will equal to negative cos x squared. So don't save this example. We will write like this. The top part will be this, that's just the same, but the negative part, the bottom part will be this. That's what we have agreed. When they cancel each other, get this, and this, when we approach x equal to pi over 2, you find that there is nowhere to replace, hence our answer will be negative 1. So these are the things that you should mark. We also have another theorem which is just similar to the first one, theorem 29. In this case, we have sine nx over nx over equals 1. So for the first one, we had only x over x, but for this one we have introduced an n. So this should actually indicate us, say, when we have 2 here, we should also have 2 here. When we have j here, we should also have j here for us to equal to 1. Just one and the same. So we have been asked to find the limit of 2x squared plus x. We have x approaching 0. So the first thing that a master is actually to write the top part as it is, 2x over, we factorize down here. When we factorize plus 1. We're getting this. So save this, don't trouble. So I've signed limit as x approaches 0. I'll sign this 2x over x multiplied by 1. Mind you, I've just factorized here. I've just factorized. So for us to have a similar term here, here it's 2x. For us to have a similar term, we can just introduce a 2 here and a 2 here. You see, we have a similar term, which when this one cancel, it will be just one and the same. So when you just introduce a 2 there, in this case we'll get a 2 multiplied by 1, and here when we approach this 2 here, just find that we are having a 1 this side. So we overall what we just have, it's just 1, which will equal to 2. So this is how you deal with limits. We also have what we call limits of exponential functions. Limits of exponential functions. First, we have this one, which is x over. How did I get this answer to say the limit of x, the exponential x, the exponent x equals to infinity as x approaches infinity? How did I come up with this? There we should use logic. Let's say we get a number, an infinity number a, then we put an exponent. It will mean to say the number will just be an exponent. The number will just be an infinity. It will just be going because of the infinity. But let me assume to say as x approaches negative infinity. So this is not something that you should master, you know by heart, to say this is equal to this, but as it is approaching negative infinity, let's say we have this will actually, let me just write properly. Let me say we have this will, it's one and the same as this. When you go back to the rules, just one and the same. So when we approach here, if it's infinity, then we'll have 1 over infinity, which is equal to 0. So these are the things that you should master when you have an exponent function, and here we are having infinity. Like this case, we are having a 0, something that you will not even master if you know how to derive. So let's say we have the exponent of this equals, as x approaches infinity. How is it? It's just 0. Thing that I've just from explaining. So we have an example which is saying the limit of exponent 2, you just write properly, of the limit, the exponent of 2 minus 4x minus x squared. So the first thing that should look is the higher power, which is negative 8x2, as x approaches infinity. So when we look at the higher power, it is holding a negative sign. So since it is holding a negative sign, should indicate something. The overall thing here will be equal to this. Since it's holding a negative sign, which is actually 0. So these are the things that we should know how to derive it. Let me give you another example where we have the limit of the exponent t power 4 minus 5t squared plus 11. You notice to say we have been asked as x approaches infinity. So one thing that you should understand is the higher power, which is t, or as t approaches infinity, which is t. T in this case is the higher power, and it will actually result in this, which is actually infinity. So this should actually be in our arts as we are working out examples. We'll also look at limits of logarithmic functions. Limits of logarithmic functions, not something that is hard. We have log a x equals as x approaches infinity. When you just punch on a calculator, you will not just notice something. Say the number will just be going as to infinity. But for limit log a x as x approaches infinity, 0 from the positive, you have negative infinity. So these are the rules that you should master. We've been given this example, which is log 2 3x, log the base of 2 3x as x approaches negative infinity. Just notice, say, when you get a number which is negative infinity, just be going, the answer will be negative. You can test this by the calculator. Just be getting a number, big number that is heading to infinity, negative. You just notice the number will just be going to negative infinity. So we also have another example, which is limit 7x3 minus x squared plus 1 x is, we have the limit in. So the first thing that you should do is actually factorize. This will equal to, so let me just write it properly. So we factorize, we have 3, the power 3, which is this over this. Hope you are not behind. This over 3 power 3. So these are the things that you should master, you should know. These are the simple things that you should know. Here when you have times a multiplication, you have an in x3 times an in. So in the end, you just find to say we have 3 in x plus in 7 infinity plus 7, which is infinity. In this case, we just have this.